What's up, guys? Hope you're doing well today. Today, we're just gonna be touching on natures of roots. So, natures of roots, grade 11. Let me just write down the topic for us. Nature of roots. Okay. So, guys, what do we know about nature of roots? So, with natures of roots, you're gonna be seeing a lot of quadratic equations. Nah? You're gonna be seeing a lot of quadratic equations. Some of them would be in standard form. Some of them wouldn't be, and you'd have to do some things and then solve for the equation and then find its roots basically. Yeah, so basically with natures of roots, right, the solutions of a quadratic equation are normally referred to as the root. So let's start with a typical example. If I think everyone is used to this one, x squared plus 5x plus 6, right? If it was equals to 0, and then you had to solve for x, right? So we'd have x plus 3 and then x plus 2 is equals to 0. And then therefore we can conclude that, okay, if we had to solve for x, x will be equals to negative 3 or x will be equals to negative 2. So this simply implies that if we had to sketch a graph, right? If we had to sketch a parabola graph, let's say, so the parabola graph is positive, yeah? We know that it's a parabola because of the x squared, it's raised to the exponent 2. There are possible solutions. Basically, this is gonna look, so if I had to draw a rough sketch, it would look something like this. And we do agree that a here is greater than 0, right? Because then the equation initially had x squared plus 5x plus 6, where we know that we have a value and that we have a value that's invisible, which is 1, which is greater than 0. So our parabola is smiling. And then we have the values that are going to come here. So we have negative 3 and negative 2. So basically these are two unequal solutions where we have a situation that these points, right, or these solutions basically touch the x-axis because we're able to solve for x. Remember, this is the x-axis that exists here, and because we're able to solve for x, they exist in this number line, and because they exist in this number line, there are two unequal 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 real solutions in this case. Because they exist in the number line, we're able to solve for it, and hence they exist in that number line. But now another way they like linking this is, now what if we had a situation where we had an inequality? Let's include an inequality. So let's say we had now let's do another example with the same question. We're gonna say x squared plus 5x plus 6. Let's say it was greater than 0. So let's try to link it with inequalities too. So when we have an inequality that's introduced to us, we're telling that, so it's telling us that if we had to solve for x, the values of x should be greater than 0. They are positive, they are real, they are greater than 0, right? So let me just remind you of some things that if we had to, so let's solve here. So we are gonna have x here, we're gonna keep it the same, x plus 3, and we're gonna have x plus 2 greater than 0. But I know that at school they tell us that when you reach this point here, you shouldn't actually solve, you should actually make critical values, right? And the critical values here are, if you had to solve for this, it would be negative 3 and what's this, and negative 2, right? But otherwise you're going to say that but before we move on to the other parts, let me just there's this technique I learned from school. It's called, well, my teacher explained this to us and he's really good at this. So it's called Gorland. So when we deal with Gorland, right, this is basically greater than. So when something is greater than, it's when the value of your discriminant is actually greater than 0. We're going to get to the discriminant part later on in the video. And when it's an AND situation, it's less than 0. The discriminant is less than 0. So because here we have a greater than situation, meaning that it's going to behave in an OR way. This is going to be it's going to be in an OR situation form. So in this case, we have an OR situation here because it's greater than. So the critical values that are going to exist here is when we say that, so we're going to say that in this case, we're going to say that when this will only exist, right, when x is greater than when x is greater than negative 3, or when x is less than negative 2. And we can sketch this graph again to say that if we sketch a graph, so we know that the graph is positive, but it's not going to be the same. So we're going to sketch a graph like oh, where's my screen? Did I just lose my screen? Oh, sorry about that. So right, so let's sketch our graph. So we're going to have a graph like this. So we say that when x is greater than negative 3, right, but less than negative 2, and this is an or situation, so we're going to represent it in such a way that's like this. Because it's an or situation, it's going to exist here. And most teachers or most students normally say that this is going to be a positive, then below here it's negative, then here it's positive. Or you can represent it using arrows like this, that's also fine. And this is just to tell you that for this inequality, we're going to have a situation that's greater than, and hence the values exist outside of it, but it's still going to be real. They're still going to be real, but it's going to be outside and here, out here. Yeah. So this is with the inequality form. Let me just do this.